To get the hang of this stuff. D. Write an expression for the normal force acting on the rider's back. All right, so our final answer will be. Yes.
Can we stand this up with anything?
Can we stand that up?
Oh, good question.
Yeah.
The R is capitalized because that's how they gave it to us. AP does sometimes do this. They might use capital M for different masses. So yeah, take it whatever's given to you. So little r and capital R technically do mean different
So it's
things.
just because this.
Little r is like a generic radius. Capital R is a specific radius. Good question. All right, so D, write an expression for the normal force. So our final answer will be Fn equals in terms of M,
Oh my
R,
God, it's Jamie.
and any other fundamental constants. What are the fundamental constants that would be relevant here? Gravity.
Yeah, gravity.
Absolutely. All right, so let's go ahead and do that. So we know here that the net force is the normal force because gravity and friction cancel out.
Obviously.
In circular motion, the net force is the centripetal force, which of course we know is mv squared over r. Can we have m in our final answer?
Yeah.
Yes. Can we have v?
No.
No. Do we have an expression for v?
Yes.
Yes. What is it?
2R.
2r. Can we have r?
Yes.
Good. Can we have lowercase r? No, but what can we have? Capital R. All right, go ahead and simplify that
Capital R.
expression. Solve for normal force.
It's all from normal, bro. What is M?
Solve for normal force. What do you get?
Yeah, but what is M? Yeah, but what is M?
What happens to one of the r's?
Oh, wait.
So I get 4mr, and then it's a force, so I'll throw newtons over there.
You can chat to him.
Just to make sure we understand. Units.
Oh, so it's 4.
Questions?
I got it wrong too.
All right, let's take a look at part E.
Wait,
Write
what
an
happened?
expression for the upward force that prevents the rider from sliding down. What is that upward
Wait,
force?
how the fuck did you...
Friction.
Oh, because one of the R's cancels out.
In terms of M, R,
What was the
and
units?
any other fundamental constants. What are other fundamental constants? Gravity. Okay.
Makes sense.
Now, we just told you the force of friction is what we're talking about. Going back to my free body diagram, what is the force of friction the same as? Force of gravity. What is our expression for the force of gravity?
FC.
Can I have M? Can I have
Yeah.
G?
Yeah.
All right, so the force of friction equals mg. It's a force. I'll say units. You really want to be picky or show you know what you're talking about? You can say up.
I'm picky.
What am I doing? Nothing much.
Who said
All
that?
right, hard up.
Oh.
Let's suppose
It's Jamie.
that the weight of the person in this
It's fine.
situation happens to be the maximum weight that static friction can hold up. If you've been on these rides, you can see that maybe kids or little kids or lighter people, it's easier for them to stick to the wall compared to somebody that might be larger. So we have here the person
You should
weighing more
go in the
static
group chat
friction will be
and post
overcome.
it. Post the
Write an
link.
expression for
Post the link in the
mu
group chat.
in terms of M,
Trust.
R,
Right,
and any other fundamental constants.
Right,
What's the
Nathan?
fundamental constants?
I mean, we're gonna have all this recorded up, so we
Now
can go
we
back
gotta
over
get
this.
U in there, so what pops in
This
your
might be the
head?
strat.
Force of friction. So the
Yeah.
force of friction equals mu Fn.
Mu FM.
Do we have an expression for the force of friction? Absolutely.
Yeah.
Answer from part E. Do we have an expression for abnormal force? Absolutely. That's our answer from part D. Plug those in, solve in terms of mu.
Why are we looking for mu? 1G, what do we have for this again? equal to 4mr. 4mr. So mg is equal to mu 4mr. Yeah. And then what was m? M was what? Yeah, he shot mu. Yeah, but what's mg? G is 10 still, right? G is still 10, right, Nathan?
You don't actually put in numbers.
Huh?
You don't actually put in numbers.
Why
You're
not?
just solving the
Yeah, you thought
theoretical
you're doing
equation.
math.
All right, what do you get for that expression?
Whoops.
Doing kinematics.
That sucks. I hate those.
Gravity equals move forward. I think.
Sucks. I hate that so much, man.
And then what are the units on mu? None. There are none.
Where'd you get mu by itself? I didn't want that.
That makes sense. Yeah, that makes sense.
Never mind.
Yeah, you divide G by 4R and you get mu by itself.
All right, let's take a look at the last part here. Suppose the ride slows down, which I showed you, but you want the rider to still remain flat against the wall without slipping. With the coefficient of static friction mu, have to increase rougher walls, decrease smoother walls, or remain the same.
Rougher walls.
Hopefully that's a pretty obvious answer that
You
it
have
needs
to
to
increase.
increase.
Yeah.
Now the challenge here is justifying your answer. Justifying your answer. So let's think through this. We know that the coefficient of friction is going to have to increase. So let's think through this here. So the force of friction equals mu Fn.
Mu. There's so many girls.
So we got to tie this in here. The force of friction.
Yeah.
Mu
To be
Fn
honest,
is mu,
no, I
and then
didn't.
I'll call it mv squared over
I don't know
r.
how girls will do it.
Thanks. That makes me feel so good.
The force of friction, we want that to remain the same so they get held in place. What else is staying the same here out of these variables? Sorry, out of these four variables, what's staying the same? The radius and
Mass. Yeah.
what's happening to the velocity? Slowing down. So what has to happen in order for force of friction to remain the same? If this goes down, what has to happen with
M
coefficient of
goes up.
friction?
Go.
Mu goes up.
I was just kind of thinking through that, right? So as the speed decreases, that coefficient of friction's got to.
Well, if the mass and radius are staying the same, Carl, right?
There needs to be something to counteract.
Yes, exactly. There needs to be something to make it equal still. So if velocity is going down. I actually get that. I get why this
That makes a lot
makes
of
sense.
sense.
Yeah, because these two have to stay the
Just gotta
same.
think how one
You're not
thing
going to change
affects
the
the
mass, and you're not going to change the radius of it.
Just like
Dude,
that.
the
guy
fact that
with
you're
the
actually
vertical
getting cooked by
loop.
Tony is
You know, it's got to be going
hilarious.
fast enough to account for friction. And if you notice,
Well, listen, buddy, you can fail your next test on passing this shit.
Oh, there's two
High-grade
people.
sandpaper.
There's two people.
High grade, yeah, that's
Pretty wild.
you know anything about sandpaper.
Probably your
Finer
girlfriend.
sandpaper,
Hmm?
so you
Probably
still
your
got some
girlfriend.
traction there to
Oh,
push
yeah.
off of.
Oh, wait. Oh, no, there's
It's
one.
non-existent.
That was one again.
Oh, that's why. What's your girlfriend?
Yeah, there's one again.
All right, go to the
He's
back
going to make
side.
such good use
Go to
for
the back
that.
side of the roller coaster loop. I'll help you out with one of the problems on the homework.
What a nice guy.
So this is it's a challenging problem, homework 2D, number 7.
I can't get it down.
So we'll get the setup here.
Wait, hold up. Ryan, share it, bro. Yeah, share it. Go on your phone. Go on YouTube. Girl, say hi. This is the recording of the class, so I can go back over this later.
On YouTube, you said?
All right, so we have here.
YouTube,
Let's
said?
think through this here.
No.
There you go. All right, so
Yeah,
roller
yeah, I got
coaster is
you.
going over the top of a hill. So in this case, going over the top of a hill, so different from an upside down loop. All right, so going over the top of the hill on a circular rise. So at the top of the hill, the passenger feels light. So now let's make sure we understand this. So you're going up here, and I'll just pause right there at the top. All right, so when you're there at the top, it already says it, but let's think how you feel. When you're going up this hill, do you feel heavier or lighter?
I'm going up, you're gonna
Hopefully you think, okay, I feel lighter.
Yeah,
Because as
you
you're
feel
going up,
lighter.
you kind of come out of your seat a little bit, so the normal force doesn't have to work as hard as supporting your body weight.
It's
Are we
scary.
good there?
Have you ever
In this
like gone in
case,
a car and hit like a
60% of
bump
their true
and
weight
it's like
weight being the,
you think you're gonna fly out the front room?
All right, so you feel
It's
lighter as you
spooky.
go up. That's
Did
why
you?
I think your stomach might kind of lift up. All
Oh,
right.
it's
Your stomach drops in order for that to happen. Your stomach has to lift up first.
I can't
in order to
see.
drop. Just like that like boat rocking ride. Little kids can handle it. As you go over, they're less and less fun. All right, so top of the hill tells us you feel light with an apparent weight over force of only 60% of their true weight. We want to figure out how fast the coaster is moving.
Why are you playing
at that.
footsie with me,
Because
bro?
it's a different speed of the roller coaster, you're going to feel a different amount of your actual weight. All right, so let's go back to the paper. And if you remember right, apparent weight. When it talks about apparent weight on here's some homework, that is normal force. All right, you got the loop. So at the top here, we got to draw a free body diagram here.
Love
You want to
those.
draw a free body diagram with the forces acting on Iron Man there. So what do you got? Gravity down, and what direction is normal force pointing? Look at the guy. Up.
Nope.
So notice how that's different
It's
than
on
the
the
upside
outer
down.
side of the loop.
He's on the top.
It's on the
He's on the top, yeah.
So the normal force is still supporting your weight, pushing you
Let's
back
see.
up, compared to if you're upside down, then the normal force is pushing you back down. All right. The radius here was 16 meters. Don't worry about that. We want to figure out the velocity. Okay. So we have our free body diagram. Then what do we do? All right. Set up our net force expression. Apply Newton's second law. The net force is the centripetal force, which in this case I got normal and gravity. Are they working together or against each other?
Against.
Now, key thing to know here. The normal force is 60% of the force of gravity.
Why?
The force of gravity is 100%
Oh.
of the force of gravity. Okay. So don't necessarily worry about the negative, think in terms of an absolute value. So how much of the force of
Nobody got
gravity
done.
is the centripetal force?
Elena.
They're fake.
It's 60 minus 100.
Fake friend.
40%.
40%.
If you really want to think of it like absolute value bars, that might help. It's a magnitude.
Not 400, 40. Simple mistake, I swear.
Questions so far? This is what makes it challenging. All right, so now we have there the centripetal force, which is mv squared over r, equals 40%, which is a decimal is 0.4. The force of gravity, which is what equation? What happens to mass? Cancels. Good. They didn't tell us anyway. So we solve this expression in terms of v, velocity equals 0.4 gr square root.
Yeah. Sounds about right to me.
All right, so that helps you out, of course, with number 7 on your homework. Yes. Yeah.
Nobody had one.
Yeah, it's still like the same.
What a shame. Well, I
Yeah,
think
like
I'm
you
gonna
know
end.
that you're like on this on the
Because,
track now. I'm trying to think here.
It's
This, you're a bad
no,
man,
risk
you're
of
like
cook.
this. So you'd still have the normal force.
Dude, the FPS immediately dropped,
Yeah. Yeah.
which is on the floor.
It's where the track is relative. Because in Batman, the track, if you're just going normal, the track is above you. Right? Because you're hanging. So that when you're on a loop here, the track is beneath you. Not like you. So when it's the same feeling as that.
James is here.
Wait, never mind.
James is here, bro. James. We gotta restart it now. We gotta put it back up here.
Hopefully that you're in that seat. That's
Like
that
this, yeah?
goal. Still pushing
Yeah?
back.
How did we have it before? Ryan, like this, right? Yeah? Now put your paper like this. One more thing. It's this guy.
What class?
Bro,
All
read,
right,
is it?
read the title, you
That-
fucking
that-
jackass.
perfect. All right, so the remainder of today, the goal is you have those concept builders done. All right, we have those 2 concept builders, and then homework 2D. Ideally be completed. We do move on.
We're gonna finish the lab.
Next class, the gravitation stuff.
And turn the lab.
And then we also have a reading.
Math? James, this is not math. Buy James. Because James popped on and immediately crossed right off. Bye. Our iPad's on 11%. I'll cook it on.
James is a
He kind of is. Okay. Guys, what's the concept builder called again?
Felix Aubeck.
What?
Nothing.
Bro, hop off. Well, now we gotta. Well, like this. Yeah. Yo, Ryan, say hi.
Nah, I'm good. Well, that's me.
No, just put it on Nathan.
Not Nathan.
Nathan's
Let's
the
go,
goal.
Nathan.
Who's putting it on?
You didn't notice me.
Carl. Yeah. Yeah, great job, Carl. Great job, Carl.
Go to MLM.
I'll end the stream.
Do it.